so we can analyze it easier. Okay, so here's a problem. You just have to draw it up because I didn't print it out for you guys.
Is it in the packet?
No, it's not.
That's a good one.
What?
Forced couple system.
Yes, so, well, let's draw it first, right? Maybe we only need it on one side and I can write on the other side. Okay, so it's an equivalent system problem. Which type of equivalent system problem? Is it a force location problem or a force moment problem? Say it again? Force moment. So, why? How do we know that? It says replace the three forces shown by an equivalent force couple system. Remember what you know how I said that many times when I try to have to turn a bolt, I first try to do it with my hands to see if it's loose. And if it's not loose, then I take a wrench. Well, when I do it with my hands, I'm actually having a concentrated, I'm trying to apply a torque to it, or trying to apply a moment to it, right? But in the end, what am I really doing? My fingers are pushing down on this side, and my thumb is pushing up on that side. What am I actually doing? I'm applying a moment, but by a couple. So now that the term couple has been introduced to you, these two words are synonymous. I'm not sure if I spelled that right.
Close enough.
So these words are synonymous. Now, I don't like that they're synonymous. I like it to use a couple when there are two forces opposite direction, same magnitude, and a moment is a moment. But since a couple produces a moment, sometimes they say couple instead of moment. So what we're looking for is the force moment system. So Lonnie, what's the first step?
So try to find the resultant.
Try and find the resultant force. Okay, so the sum of the forces is, what do we have? We have a negative 100 I minus a 100 J. Newtons or pounds? Pounds. And if we wanted to find what the resultant really is, how would we find the resultant? We have the I and the J squared. So it's 100 squared plus 100 squared. The radical, I think it's 141.1,
Yeah.
0.4. Okay, what's the second step, Sarah?
Some moment.
Right, find the resultant moment, right? And are they telling us a point where they want us to find a moment about? B. Okay, so you want to give me that? It's the first 100 times what?
100 times
right? Positive, negative, right? And then 200 times 20, positive or negative, right? And then 300 times 14, positive or negative? Negative. Anybody have done it differently?
Couples.
Look at the couple. Claire, you want to tell us what you would do?
I would split up the 300 into 200 and 100
Okay,
and use the two 200 couples to
so it'd be 200 times
6
6, positive or negative?
negative,
Try again.
positive.
Positive, right? And then you would have this leftover 100,
Mm-hmm.
and you'd have to multiply it by 14,
Yes.
negative, and then still keep that 100.
Mm-hmm.
Is that 100 and this 100 a couple?
No.
Is that 100 and this 100 a couple?
No.
Why not?
Parallel.
They have the same magnitude, but they're not opposite in direction. So what does this turn out to be? 4,000, 1,000, 5,000 minus, what is it? Say it again?
That's what inches. 800.
800, and it's inches? Inch, pound, positive, right? Now, it's a force moment system, so what's the next step, Janae?
To draw the body.
Draw the body, which looks like this. And where's point B? Point B is out here. And this is 8 inches, 12 inches, 10 inches. And so what do? I draw the body, and now, Janae, you want to keep going?
You have to add the resulting force.
Okay, in the drawing, draw it in the resultant, so I have a resultant force of 141.4, and if I look at the components, 100 and 100, so how should I draw it? Which way?
It'd be going down.
Great. Does everybody agree that this resultant force is going down? It has a negative x component and a negative y. And I need to have an angle here or something, right? So what could I do? I could say 1, 1, right? Could I put a 1, 1 there? Right? Or I could have put 45 degrees. Sam,
I was gonna ask if you needed to indicate an angle.
you knew, because this is a free body diagram, right? It needs to have an axis, it needs to have the forces labeled, and it has to show a direction. Rachel, what else do I have to do? Do the moment. And is it positive or negative? And the moment is equal to, I don't even have to write M, I could just say 800 inch pound. So applying 141.4 pounds in this direction to point B and spinning it at 800 inch pound is the same as this system. Even though this problem asks us for a forced moment, let's do a forced location for the same problem. And by the way, this is my own terms, force location system. They'll say find a force at a location, but I call it a force location system. So Kyle, what's the first step of a force location problem?
Draw the body with the resultant force.
That's the step that we could go to now because we did half the problem already. But if we were starting from the beginning,
Perpendicular distance.
again, but let's go back. Had we not done all this, the first step of the equivalent system, regardless of which one, we'd have to find the resultant force. But we already found it, right? But I'm just going to write this step anyway. And we found that it was equal to this. Second step was find the resultant moment. which we already did too, because the first part of the problem asked us for a force moment system. Then Kyle, third, what's the third step?
Find the perpendicular distance.
Perpendicular distance is equal to the absolute value of the moment divided by the force, which is 800 divided by 141.4. And what does the perpendicular distance turn out to be? 5.65? 5.66 inches, right? Okay, well, step 4. Chelsea, or no, Chris, what's step 4 now?
Would be to actually draw it.
Draw it. So let's draw this bracket again. We have 8 inches here, we have 12 inches here, we have 10 inches here. This is point B. And what do we have to draw?
Go to the right 5.68 feet and make your 45-degree angle.
Great. So we have to draw a force of 141.4. It's in the same direction as what we drew already. It has a negative x and a negative y. But we have to decide where it is. Well, we're looking at point B, right? It could be drawn here, down to the left, and it could be drawn here, down to the left. Right? Because I know my perpendicular distance. My perpendicular distance is 5.66, right? But I don't know if it's at position 1 or position 2. So Chelsea, where is it? Is it at position 1 or position 2? How do you determine which position it is?
Wait, it's gotta be position
Positive and
one.
negative.
You gotta reuse your right-hand rule. So your moment is positive, right? In order for this to create a positive, which one is it? Position 1. So it's gotta be here. We know the force goes down to the left, so it's going this way. It's gotta go this way. We know the distance is 5.66, but we have to figure out, does that force, is it above B or below B? Well, when it's above B, it creates a positive moment about B. But if it's below B, going in the same direction, it's going to create a negative moment, so it can't be here. And then we label it. The force is equal to 141.4 pounds. And the perpendicular distance is 5.66 inches. A lot of people have problems with this, so a lot of you are still confused. Okay?
Do we have to like show the angle between
Oh,
I
we
guess the
forgot to do that.
horizontal line?
Thank you. So either we have to say it's a 1-to-1, right? We either have to do that, or we have to say it's 45 degrees, thanks.
Okay.
The free body diagram is missing something, right? It doesn't have the axes either. -2, -2, they actually takes off a lot of points.
I'll get -5s, I don't know.
She likes
If you have questions, on how I did the point spread, you could come to see me. Santiago came and I went over all the numbers. So yeah, you have to show the direction. So what do you prefer? I mean, you guys like angles, I think. So you probably would put a 45, I like 1-to-1.
So would you put an angle on the other line, the distance line too, or around
No.
the box between them?
No, because we know
Okay.
that it's perpendicular. You calculated the perpendicular distance. Bless you. Chelsea,
What, could you have that perpendicular distance be flat? And then have the
mean
arrow
right
go
here?
down? Yeah.
yeah, you could do that. Let's, can I erase all this? It complicates things, but it may be more comfortable for some of you. But you'd be finding a different distance then. Right, so let's erase this. This is 8. Okay, so, if you want to continue the line of this and continue the line of this, you could find out this distance if you want, and then draw it down on this line.
So when
But
you,
then you have some geometry to do, right?
okay, I see.
Probably wouldn't do it.
Yeah.
Okay, ready for a 3D? Can I erase this?
I wanted to